Today I'm going to start with the practical portion of time value of money. The time value of money can be divided into two parts. First, deal with the process of compounding, and the second part deals with the process of discounting. When I use the word the process of compounding, it means I am adding something to it or I am multiplying something to it. And when I use the word discounting, it means I'm subtracting or I'm dividing something. So this is the timeline. If I'm going from 0 to 5, I'm talking about the future value. And with this compounding, we calculate the future value. And if I want to come back from the timeline from year 5 to year 0, I'm taking care of the process of discounting. And through the discounting, we calculate present value. So in this chapter, there are four tables which we have to follow. First is FVIF, which means future value of interest factor, which is table number 1 or A. Second is future value of interest factor annuity. Future value of interest factor annuity, which is table number 2 or B. And the third topic which we are going to cover is PVIF, which is present value of interest factor, which is table number 3 or C. And the fourth type of questions is PVIFA, present value of interest factor annuity. PVI, table number 4 or D. So these are the four concepts. These are the four concepts which we will learn in time value of money. It can be easily divided into the process of compounding and the process of discounting. In the compounding, we have two things, FVIF and FVIFA. In the process of discounting, we will calculate present value, PVIF and PVIFA. Apart from these, we are also going to have the concept of annuity due. The concept of annuity due, which is future value annuity due and present value annuity due. So these are the six concepts which we will cover in our time value of money. I am starting with the first topic, which is the future value. In future value, we can divide it into future value of single lump sum payment. Single lump sum payment. And second concept will be future value of unequal multiple payments. Multiple payments. Now, the formula for this is FV is equal to PV 1 plus K raised to power N. FV is the future value, PV is the present value, K K is the interest rate, and N is the number of years. Number of years. Suppose, let us do a question. Suppose an amount of 10,000 rupees today is invested in a scheme, and what amount will it grow? What amount will it grow after 3 years if interest rate is 11%? If interest rate is 11%. So the formula will be FV is equal to PV 1 plus K raised to power N. This is 10,000 PV 1 plus K 1 plus 011 11%. 11% means 11 by 100 or 0.11 raised to power 3. FV is equal to 10,000 into 1.11 raised to power 3, and we have to use table number 1, which is FVIF table. If we see the value, now if we want to use the table, we have to write FVIF 11% comma 3, means at 11% and at 3 years we will get the value. That value will comprise, it will be a calculated value of this thing. So that amount is coming to 1.368. So 10,000 into 1.368, which is coming to rupees 13,680. So this is the amount which is calculated by using the table. Table number 1, we are doing future value of single lump sum payment, and the answer is coming to 13,680. I hope it is clear. Let us go to the next topic, which is future value of unequal multiple payments. Again, the best method is to make a timeline. So the question is, suppose we invest rupees 1,000 in the beginning of first year. We invest rupees 1,000 in the beginning of first year. First year starts from 0, ends at 1. From 1, second year start, ends at second. From second, third year start, and it ends on 3. Okay, na? So 1,000 rupees is invested in the beginning of 1 year, first year, in the beginning of second year, and in the beginning of third year. Now the percentage is given. K is given 12%. K is given 12%. Now please make a timeline. Now we have to calculate what will be the amount. What will be the amount after 3 years? First of all, we have to see what we are planning to calculate. We are going in future, so it is a future value. So what will be the amount if I invest 1,000 rupees in the beginning of first year, 2,000 rupees in the beginning of second year, and 3,000 rupees in the beginning of third year? So 1 year, 2 year, 3 year. 1,000 into 1 plus K raised to power 3 plus 2,000 into 1 plus K raised to power 2 plus 3,000 into 1 plus K raised to power 1. Same formula, FV is equal to PV 1 plus K raised to power N, and our K is 12%. 1.12 raised to power 3 plus 2,000 into 1.12 raised to power 2 plus 3000 into 1.12 raised to power 1. Now this is future value of multiple unequal payment or receipt. So we are going to use the table FVIF 12%, 3 plus 2000 into FVIF 12%, 2 plus 3000 into FVIF 12%, 1. So if we look at the value in the table, we will use table number 1. We will always use table number 1 if there is a single payment or there is a multiple unequal payment for future value. Table number 1. For table number 2, we will use when there will be a annuity. Annuity means multiple equal cash flows. Multiple equal payment or receipt. It is called annuity. Annuity will be coming in the next video. So 1000 into the amount is given in table number 1, 12%, 3 years, 1.4049 plus 2000 into 1.2544 plus 3000 into this is 1.12. If I calculate this whole amount is coming to rupees 7273.7. I hope this is clear. Future value of single lump sum payment and future value of unequal multiple payment. Thus, the calculations are similar. Only in multiple we are calculating individual and then adding it up. Whereas in single we are only doing this part only. The formula will be FV is equal to PV 1 plus K raised to power N. Now I am coming to the third concept in future value, which is FVIFA. Now the third concept is FVIFA, future value of interest factor annuity. Annuity means equal payment or receipt every year. Every year. The formula will change. Future value annuity is equal to A into 1 plus K raised to power N minus 1 upon K. FVA is future value annuity. K is interest rate. N is number of years, and A is the annuity, amount of annuity, which means on the timeline, if I am investing 5,000 rupees every year, so I can easily calculate using this formula. So I will be using table number 2. So this FV A annuity into 1 plus K raised to power N minus 1 upon K. This whole thing can be written as FVIFA K percentage comma N. When I write FVIFA, I am using the table number 2. Let us start with the question. Suppose a firm deposit 5,000 rupees at the end of each year. 5,000 rupees at the end of each year. If it is not written anything that it is in the beginning of the year or at the end of the year, please assume it that it is at the end of the year. If it is written it is in the beginning of the year, the concept will change. It will go to future value of interest factor annuity due. So in this we are only calculating future value of interest factor annuity, and it is for K is 6% and it is for 4 years. So the formula is FVA is equal to annuity into 1 plus K raised to power n minus 1 upon K. FVA annuity is 5,000. Simply write 5,000. K is 6%. N is 4. So this whole thing you need not calculate it. Kindly use the table FVIFA 6%, 4 is equal to future value annuity. Now the value in table number 2 at 6%, 4 years, you will see the value of this whole statement. This whole calculation will be done. Please never divide it. You have to multiply it with the annuity. The amount is given 4.3746 into 5,000. So the answer is coming to rupees 21,873. This is the value of annuity for 4 years at 6% rate of interest. So you need not calculate it. Please use the table FVIFA 6%, 4, table number 2. And similarly, if it is a case, the last concept in future value, future value annuity A into 1 plus K raised to power n minus 1 upon K. This case, when we are receiving the amount at the end of the year. But if in the question it is given that you are receiving the amount in the beginning of the year, beginning matlab at point 0, at the beginning of the year, equal payments or receipt at the beginning of the year, it becomes the concept of annuity due. It becomes the concept of annuity due. If I say formula will change, annuity due A into 1 plus K raised to power n minus 1 upon K into 1 plus K. अगर आपका annuity due का concept है, सिर्फ 1 प्लस K को मल्टीप्लाई कर दीजिए, आपका आंसर आ जाएगा. इसके बगैर सिंपली आपका फ्यूचर वैल्यू एन्युटी टेबल नंबर 2 ही यूज करना है. इसके अंदर सिर्फ जो भी अगर एन्युटी ड्यू है तो 1 प्लस K से मल्टीप्लाई कर दीजिए, आपका आंसर आ जाएगा. यू हैव टू स्टिल यूज टेबल नंबर 2. ये पूरा पोर्शन टेबल नंबर 2 से लेना है आपने, और जो भी होगा उसको मल्टीप्लाई कर देना 1 प्लस K से और A से, आपका फ्यूचर वैल्यू एन्युटी ड्यू आ जाएगा. आई होप दिस इज क्लियर. इन द नेक्स्ट वीडियो I will start with the present value concept. Thank you very much.